Hey everyone, in this video I want to explore the upgrade options and the mechanisms we need to do for our Azure Kubernetes service. When we think about AKS, it's obviously a platform as a service. When we think about who is responsible for which component, well, that Azure Kubernetes service, it's responsible for things like the operating system, the patching. But as with many things, there's a certain amount of shared responsibility, and there's certainly things I need to be aware of as the customer of AKS to make sure I stay current, to make sure I'm running on a supported version. And that shared responsibility is really important for many things, and especially Kubernetes. If I think about using Kubernetes, there's a certain contract that's understood between me as the user and Kubernetes that I am going to stay current. I am going to stay on a supported version of Kubernetes. I need to really think about having process and procedures to make sure, hey, I don't deploy Kubernetes and then stay on that version forever. I need to make sure I'm staying on a supported version, which is what we're going to explore. Now, yes, if I need to stay current on that Kubernetes, it means I need some set of processes around, well, hey, I'm going to this new version. Have they maybe deprecated some API? I need to be aware of that, but that should be part of my all-up DevOps process. It's no good working with Kubernetes and, hey, I need to stay on this version for 3 years. That's just not going to work. Now, obviously, if we talk Azure Kubernetes service, the whole point of this, it is a managed Kubernetes offering. So when I think AKS, what we're actually doing is we are running Kubernetes. This orchestrator, this platform for containers. And if we talk about Kubernetes, there are two planes that are involved. There's the control plane, and then the nodes that actually run the pods that run our containers. Now, if I think about this control plane element, so we're dealing with the Kubernetes, and I have our control plane. And this control plane is invisible to us. It's fully managed. We don't really interact with it. Now, that control plane has things like our etcd stateful database. It has things like the API server, which is what we talk to when I'm interacting through kubectl. When the kubelet in the nodes is communicating, it's all via the API server that then goes and talks to the etcd database. There's things like the scheduler, which says, hey, I've got these new pods requested. They're not scheduled yet on a particular node. Hey, I need to go and place them. Then there's various controllers and the controller manager. This is all fully managed. I do not interact, I do not manage or really do anything with those components. I see an endpoint to my API server. That could be a public or it could be private. It's projected in maybe via a private endpoint, or now we actually have that VNet integrated API server into our virtual network. So if that's the control plane, then we have the nodes. And the nodes, well, today they sit inside our subscription. It's built on top of a virtual machine scale set. So I can absolutely think from an Azure perspective, so we use blue for Azure, I have the idea of nodes. So there's going to be multiple nodes. So the node, from an AKS perspective, well, that's a virtual machine. And what's actually happening is we have a node pool which builds on top of a virtual machine scale set. So that's really that core construct inside there. So we've got the node, which sits within a node pool. And a node pool is made up of n number of nodes, and I can have n number of node pools within a particular AKS cluster. So that's the core thing. Now inside this node, it's a virtual machine. So obviously we have an operating system. There's a certain operating system, normally Linux, for example, Ubuntu or Mariner. It could be Windows Server 2019, 2022. And then we have various components of Kubernetes that run inside that operating system. Now, obviously, there's things like the kubelet. Remember, it's the kubelet that actually communicates with the API server. But there's also other things. There's containerd. So we have the actual container runtime. There's things like kubeproxy. So there are aspects that run in the OS that are part of, hey, being able to run Kubernetes. Obviously, containerd is not part of Kubernetes as such, but I need it to be able to run containers. And then, of course, we have pods. So we actually have pods, and again, we have multiple pods, but there's a certain number of system pods that run key components that make Kubernetes work. Things like core DNS, for example. And if we go and look at a node and the workloads, we'll see a whole bunch of system pods running. These are critical to the overall picture of Kubernetes working. So when we talk about Kubernetes, the important thing here is, hey, it's not just one thing. There are multiple aspects to it. Yes, the control plane, but then actually the node pools, there's a VM scale set that's comprised of VMs, the nodes, that then have, hey, it's an operating system, Linux or Windows, but then components that run inside that OS, and then system pods that run on top of that container runtime that are all part of that all-up process. So if I think maintenance and upgrade, yeah, hey, I have to think about the Kubernetes control plane. I have to think about containers that are actually running on the nodes, these system pods. I have to think about components that are part of Kubernetes. And then more, I need to make sure that OS is maintained and patched and current as well. If I think of Kubernetes, let's take a step back and we think of versions, we're talking about upgrades. So Kubernetes over here, it uses the idea of semantic versioning. And what semantic versioning means is I have this idea of a major, which would be, hey, if I change the major version, it's some breaking change to previous versions. I have a minor, and then I have a patch. So for example, I might see a current version of 1.25.3. Major is still version 1. We would not expect that to change very often at all. Now, in terms of the minor, well, the way this is working right now, it used to be every 3 months, but this is now approximately every 4 months. There's some variation in that, but that's what we really see. If we go and look at the releases, so let's take a look at where we are right now. What I'm really going to look at is the version, the .1. So I can see 25.1, okay, basically middle of September. Before that, well, we had kind of middle of May. Before that, well, actually that was middle of December. So it's every kind of 4 to 5 months. You get the idea of when these are pushed out. Before that, it was August. Now, it did used to be every 3 months, but they did actually shift because just, well, it was too frequent. Customers struggled to keep up with that cadence. So now we really think about that, hey, minor version, approximately every 4 months. And what's happening is each of these minor versions, well, each version of that is basically 1 year of support. And once again, we could see that on that same document. So when it talks about the versions, we can see all the way up at the top, it has these idea of end of life. So hey, end of life for this one, 10/27, 2023. And here you can see it was released, remember, in September the previous year. So you're approximately getting 1 year of support, and that's going to be consistent. So each minor version is going to get supported for that idea of a year. And that's really important to think about that. So, okay, there's basically every 4 months there's a release. Each minor release is supported for a year. So what that's really saying is it's really n-2. If it's 4 months and it's lasted for a year, there's 3 versions that would ever be supported. The current version, n, and then 2 previous ones. So you think about, hey, there's 3 versions supported, which goes back to, hey, I really do need to stay current. Potentially I could stay on a version for a year. That's going to get you in a very difficult position at the end of that year to have to get that upgrade going. A lot of companies will think at least every 6 months. So it's really important to get on that and stay current. And then the patches, that varies. We might say approximately monthly. However, when a new minor version is released, those patches tend to be a little bit more frequent because, hey, it's a brand new version. There are critical bug fixes found they need to get out there. And so those monthlies tend to be a bit more frequent at first. So I may see a few more of those coming on. So that's what I can think about for Kubernetes. So Kubernetes, approximately every 4 months, a minor version, they support it for a year. And I think that, well, AKS is sitting on top of Kubernetes. So if Kubernetes is really n-2, to all intents and purposes, every 4 months, and it's supported for a year, well, that's really what AKS is doing. So from an AKS perspective, if I think, okay, so we've got that major version of 1, what it's doing is really n-2. So it's minor -2. So the current minor version and 2 previous minor versions is what is supported. So in this case, if the current minor version was 25, well, it would support 25, 24, and 23. As soon as 26 is generally available, well, then 23 wouldn't be supported anymore. It's the current and 3 versions. So if I was on 1.25, well, then 24 and 23 are also supported. But hey, once 26 goes GA, well, it's n-2, so that would no longer be supported. So that's the life cycle of what is happening there. And then for the patch versions, it's the current stable patch -1. So it's supporting the 2 most recent stable patches. So that's what we can think about that AKS is doing, and that's shown in their documentation. So if we actually go and look at the calendar for AKS, it's really showing exactly what I just said. So we can see, hey, right now, for the GA versions, 1.23 to 25. And we can see when they're going to end of life. So the 1.23 is going to end of life when 1.26 GAs. And 1.26 is expected to GA in March of 2023. And then, of course, it would end of life when, hey, 3 newer versions available, 1.29. So you can think about it, I have that n-2 of supportability. That's really the key point. And if I think about the patch releases of what is supported, well, if we look at the Kubernetes version support policy, well, this is again where it says, from a minor perspective, it's the latest version, referred to as N, and then 2 previous minor versions. And then additionally to those 2 minor versions, it supports maximum of 2 stable patch versions for each of those minor versions. So that's really spelling out that support policy. Now, one of the nice things you can do in AKS is when I want to go and deploy a cluster, for example, I don't have to tell it the patch version. I could just say 1.25 and it will alias out the patch and just do whatever the current patch version is. I don't have to be that specific. But if I'm thinking about supportability, key point, Kubernetes supports a minor version for a year, minor version every 4 months. AKS is basically following what Kubernetes does. So it's supporting the current minor, N, and 2 older versions. So it's really matching. And that's a key point. Could I today stay on an older version outside of that? Yes, you can. But the documentation does state if you fall below, I think it's kind of N-3, they have the right to force that upgrade. Because you think about if there's some vulnerability in the control plane, they don't want that. Because if you get into the control plane, maybe I can do other things. So today, I'm unsupported, which means if I call support, they're going to say, go to a supported version before we'll do anything. There is no patching available. There's no updates. If there's a problem, Kubernetes aren't supporting it either. So I can't get changes made to the code. But technically today, I could stay on an older version in AKS, but that is going to change. And they do say in the documentation, hey, we have the right to bring you up to a supported version if you fall too far behind. Now I can view what are the supported versions. So if I quickly jump over, and let's go and look in the portal for a second. So if I jump to the portal, so straight away I'm looking at my AKS here. Let's have a look. I can quickly see my Kubernetes version that I'm running, 1.23.12. I could also look at my cluster configuration. I can see, okay, yep, 1.23.12. And so remember, this is the control plane. And then the node pools themselves, well, they have components. And I can see they're matching 1.23.12 as well. I can see what versions are available to me for a number of ways. But here in the CLI, if I just paste this quickly, I'm looking in my location and it's showing me what are the Kubernetes versions available to me. So remember, N-2. So 24 is the current. So I also have 23 and 22. And it's supporting at most 2 stable patch versions. So I can see, hey, there's 2 for 24, 2 for 23, and 2 for 22. And it also shows me, well, based on the version I'm on, what could I upgrade to? So if I'm on 1.23.12, well, I can upgrade to 1.24.3 or .6. If I was on 1.22, I can only upgrade to 1.23. Why is that? And the key point here is you can't skip minor versions. So when I think about that versioning, if I was on 1.23, I can only go to 1.24. I can't skip it and go straight to 1.25. If I'm on 1.24, I can go to 1.25. Now, if I'm outside of the supported versions, if I was on 1.20, then I can skip. At that point, I can just skip straight to a current version. But if I'm in the supported versions, I can't skip a minor one. I can't go 1.23 to 1.25. I'd have to go to 24, and then I can go to 25. And we're going to see that when we look at our environment and what we can do around those. So I can easily see what's available in the region, and I can also see, well, what's available to upgrade to based on my current version. Remembering, I can't skip minor versions. Is there ever exceptions to this? So we're saying AKS supports the current minor version and 2 previous ones. So 1.25 is the current GA, so they support 24 and 23. What about, do you know, I've got a ton of development work. I want to stay on 122 for an extra year past it going end of life. Will Microsoft do that? No, they won't. Forget about the amount of additional work that would be for Microsoft to then add that to the test matrix, to add that to the images that have to get built. What would that support by AKS really mean when you consider Kubernetes has stopped supporting it? It's end of life. They're not supporting it anymore. They're not patching it. There's no updates if there's some severe security vulnerability found. Would you really want to stay on a version of Kubernetes in AKS that's no longer supported by Kubernetes? I don't think you would. What would this support really consist of? Hey, there's this critical vulnerability found, or this is just crashing. and it turns out to be a Kubernetes problem, there's nothing Microsoft in AKS could do. I guess they could sympathize. I can support you emotionally. I'm so sorry that's happening to you. That sucks. You wouldn't want it. So the idea of, hey, can I stay on a version that's not supported by the underlying vendor is fundamentally a bad idea. You don't want to do that. So I'm in this contract with DevOps. I'm in this contract with Kubernetes. I'm going to stay current. And again, that every 6 months is a really good thing to do. When a version is going to get retired, they announce it in the release notes. So if I go and look at the latest release notes, for example, so this is the current weekly build, it's reminding me, hey, 1.22 is being retired on December 4th. Please upgrade to at least 1.23 before that. It gives me all of the details of what is coming. So you're given plenty of notice. If I go and look at the older release notes, it mentioned the same thing there. So it tells you when things are getting retired in the release notes. But you have a certain responsibility to stay current and understand what is coming with these. So, all of that said, Kubernetes advances, new functionality, maybe some deprecated APIs. AKS, because it sits and is offering Kubernetes as a managed service, it follows that and supports a certain number. So there's a new version. I would know that because, hey, it's now available in my region. And I can even go and look at my cluster I have to see, well, what's available to me, which new versions of the control plane are available. So if I was in the portal, actually, I'll show the CLI first. So over here, and I've got my cluster. What upgrades are available for this cluster? So if I paste, it shows me the details. So it's telling me what am I currently on, 1.23.12, and then it has this upgrade section. And if we zoom out, it's telling me the upgrades that are available to me. Hey, you could upgrade to 1.24.3. It's not a preview version. It's not offering me any preview versions because, again, I can't go beyond the next minor version. And currently, I'm what's considered stable. I'm one below what is currently generally available. Or I could go to 1.24.6, the latest patch version. So it's giving me options for the patch version within that next minor version. So I can very easily see, hey, what could I actually upgrade to? But I can also see that within the portal. So if I look at cluster configuration, it's giving me this upgrade version option. And I can click that button and it will show me what's available to me. So it's showing me my current, and it's showing me those same two versions that I could actually move to. So if I selected one of these, it's actually giving me an interesting option. Upgrade the control plane only, or upgrade the control plane and all node pools. So why do I have these two different versions available to me? And I guess what I'll do is just while we're chatting, I'll kick this off. So let's upgrade the control plane. So what is this actually doing? Why am I getting these two weird options? Remember, there's really two levels to the Kubernetes environment. There's the control plane. It has to upgrade that. So it's saying, hey, I can just update this control plane. Now remember, the control plane, yes, are these components here, but there are also these system pods. So if I say control plane only, it's going to update, obviously, the control plane, and then go and fetch the updated images, cache them on the node, and update the system pods. But it's not going to update the kubelet. It's not going to update other components that are running inside there. So this is the key part when I start to think about this idea of upgrading things. So we'll use a different color. So when I think upgrade, it's always, whether I'm using the portal, whether I'm using AZ, whatever the method, it's always going to update that. Optionally, square bracket, it can update the components on the OS as well. But remember, it is still going to go and get the new images for those system pods to go and do that, go and get it from the MCR, whatever. So it has those elements in the control plane, it has those elements in the system pods, and there are things like the kubelet, the container D, the kube proxy. But you are allowed to have these running a lower version. So I can absolutely upgrade the control plane, but actually not upgrade the node components yet. There's certain policies in place to control how many you're allowed to be. The reality is, for example, kubelet can be 2 versions lower, but it can't go beyond that. And we'll look at some documentation in a second. If I select control plane only, it's not touching the kubelet. It's not touching those components. So it's not going to do anything on that OS, on the nodes itself. It's not going to re-image them or do anything else. If I say control plane and all node pools, well, it's going to update the kubelet, the container D, the kube proxy. And the way it does that update is it actually re-images. If I think about it, this is a VM. That VM is built from an OS image. So fundamentally, yes, this is a virtual machine, but out there's actually an OS image. And when I want to upgrade things like the kubelet, all of that, it doesn't go and install a new exe. It is building this from a certain OS image. So when I choose to upgrade the Kubernetes version and update the components on the nodes, it just re-images the nodes. Now, that would be pretty much of an impact. If I just suddenly said, oh, okay, I'm going to shut all the nodes down, I'm going to re-image them, everything's shut down. That's a really bad thing to do. So it does a rolling upgrade. It re-images it node by node. Then I have actual control of that. So the way it handles a node pool upgrade is there's a number of steps to the process. The first thing it does is surge. And surge is all about the idea that, let's say I had a node pool with 3 nodes. It might add 1 extra node. I can control this. I can set the surge as a percentage or a number of nodes. If I set it to 33%, which is a good production number, it's going to add that number of nodes as part of updating the node pool. So if I had 6 nodes, it would add 2 surge nodes. And that's how many it can concurrently update at a time. So it would surge, it would add additional nodes so that as it's updating a node, I'm not dropping the overall capacity. Because obviously if I had 3 nodes and I'm re-imaging 1, well, I've lost 1/3 of my capacity. So Surge says, no, I'll add a new node with the new image version you're going to. So it's basically rebuilt a new one. So I've got that new one there. So I'm creating the surge. Then I'm going to drain the node I'm going to work on to re-image. So I'm moving all of the current workloads off of it. Before it drains, actually, it will cordon it off so new things don't get scheduled on it. So I'm going to surge, cordon, drain, and then I'll re-image from the latest image version for the version of Kubernetes. There's multiple images for different Kubernetes versions out there, but whatever I'm moving to, it will now re-image it with the new image. I've not lost capacity, remember, because it added new nodes based on whatever I wanted. Once that's finished, well, that node can then become the surge node for the next, and it repeats the cycle until it's finished all of the upgrade where it can then delete that extra node. So I'm back to my original 3 or 6 or whatever that is. So a key point is this process is used whenever we talk about updating the nodes in our node pool. Whether I'm going to a new version of Kubernetes, whether I just want to get to a new image, because we're going to talk about this, the images get new things baked into them. It always follows this process. So Surge is super powerful for letting me control how many it can concurrently do within the node pool at a time. Again, it can be a fixed integer or it can be a percentage. So if I set it to 33%, again, as a recommended, it will roll up to the next whole number of nodes. So if I had 6 nodes, it would be 2 nodes. it will do 2 nodes at a time. So it will make it quicker how I actually roll out those changes. But be aware, it's creating those new nodes. Do I have quota in my subscription? I have to consider that for my surge value. And if I think about things like Azure CNI, well, I have to have IP space in the subnet, because depending on which model I'm using, hey, it has to go and pre-allocate 30 IP addresses in that subnet, or 50, depending on what my max pods per node is. Do I have enough IP space to support adding 2 or 4 or 6 nodes into that subnet? So I have to think of all of those different things when I think of that surge value. I also have to think about things like the pod disruption budget. So all of these pods, there's something called a pod disruption budget. And again, that could be a percentage or an integer, a number. That tells me, hey, in planned situations for some short-term drop in number, how many are you allowed to drop? Well, if I had that set to 0 or too small based on my surge value, it won't be able to drain it. It wouldn't be able to stop the pod to get it rescheduled somewhere else. So the drain will fail. So when I think about surge, when I think about pod disruption budgets as well, to make sure they correlate, so that if I wanted to have maybe 2 nodes surging at a time, but I also would want to be able to make sure I have a pod disruption budget that would allow maybe at least 2 pods, if there was 1 per node, to also be able to stop temporarily so they get scheduled on another node. So there's a few intertwined values I have to think about when I think, hey, node reimaging. This sounds more complicated than it is. It's just important to think about those things. So I control how many nodes at a time through surge, and just make sure you've not done manual things and setting your manifests around pod disruption budgets that might stop the drain happening. But that's what it's going to go and do. That's how it's going to update the Kubernetes version on the nodes. It just reimages the nodes, rolling, and I can control that. Hey, do all the node pools, or maybe, hey, I'll do it a node pool at a time. I do have control over that. And again, I don't have to select that. Remember, we had the option. In the portal, and like what I've done here, I said do the control plane only. I didn't say do the node pools. So if I do that control plane only, well, what it's doing, let's see what it's actually, see if it's done anything yet. Let's have a look. So it has actually upgraded the Kubernetes version. So now I'm on 1.24.6. But my node pools, well, they're still running on 1.23.12. And again, it has to stay within 2 versions. If we look at the Kubernetes SKU policy, the kubelet can never be newer than the control plane, maybe up to 2 minor versions older. So if my API server is 1.25, hey, the kubelet can be 1.25, 1.24, or 1.23. So those node pools can lag a little bit, but I can't let it lag too far. If it falls outside that, it's just not going to work anymore. So I do have to think about, if I don't say, hey, upgrade the node pools as well, I have to have some process that makes sure I do keep up to date. So our node pool is now lagging behind 1 minor version. We would see the various workloads. I can see like my core DNS, various pods I might have, etc., are running there. So I can see all of those components to me. And then if I'm in this scenario, well, now on the node pool, I can go and look at a certain pool. I have options here to upgrade Kubernetes. And again, I can't go beyond the version of the control plane. So the API server is 1.24.6. I can go up to that. So I can say, oh, sure, we'll upgrade the node pool. The other thing I have here is update image. And right now it's saying, well, your image matches the latest version. There's nothing I can actually do right now. And we're going to talk more about what that image actually means. But we might say, okay, let's go ahead and upgrade now this node pool. And what we would basically see over time is, well, we would expect to see, I've only got 1 node in here. But what I would see is a surge. I would see a new node actually gets created, assuming I had sufficient quota. And then once that surge one was set up, it would then drain, it would cordon off the existing node. It would then drain it, so the pods would be stopped and it would get moved to the other one. It would then re-image the old node, and then it could kill off the drain. Again, if I had more than one node, it would do this rolling thing, and I would see that happen over time. Because I did upgrade, let's just check one other thing. Because I did upgrade the control plane to now it's 1.24, if I now look at upgrade version, oh, okay, I don't have the preview. So sometimes there's a preview, there'd be like a 1.25 available to me. So I would see, hey, a preview, and I could go to that as well. I could also do this through the CLI. So if I go back down here for a second, I can go and look at the node pool. So if I just paste this command in quickly, within the node pool, it will show me the details of the things I'm doing. So here I can see my node image version. I can see that right there. And I can see my orchestrator version. So that's for the orchestrator. So I have data around that. I could also see, well, okay, well, what are the upgrades available for this node pool? Now, because I've kicked this off already, I may not get good information. Oh, I missed off the pool name, agent pool. It's actually not showing me any because, notice it's got upgrades null because I've already kicked this off. There's nowhere else this node pool can go because I just manually triggered it through the portal. But ordinarily, if I hadn't have done that, I would actually see that as an option. Notice node count is 2. Notice it created the new one. Here it's done that surge because it's doing that rolling upgrade. So it didn't drop me to, didn't reduce my capacity. It surges to those additional nodes. It creates it with the new version. And then, hey, it will, once it's finished and it's clean, it would kill all of that down. So the key point here is if I'm not doing it all in one go, if I'm not saying as part of the upgrade, hey, do the control plane and do the node pools, I need to make sure I remember at some point to do the node pools as well. Either manually, through the portal, through the CLI. I could use GitHub Actions. There are many ways to do it, but don't let it fall behind too far. Now, the reason I may not want to do the nodes at the same time, maybe I have multiple node pools and maybe they're different environments. Maybe I have a dev test and a prod sharing a control plane. So, well, I don't want to upgrade the prod components yet. I would rather say, hey, let's actually upgrade the node, dev test node pools first. Once I'm happy and it's not broken anything, then I could go and roll out to the prod. Although, I don't know, more commonly you might find actually my dev test would be a different control plane as well. I want to try and keep them separate. But that, based on organizations, you may do different things there. Now I can use planned maintenance for this. I can define windows of where this maintenance will happen for both the control plane updates and the various system pods that are running in there. There's also weekly windows for the weekly images. So there is planned maintenance I can specify. What's coming down the line is the idea of planned maintenance groups. So that would be really nice because there are some challenges around the way this works today. But with planned maintenance groups, I'd be able to put these node pools into different groups, and then I could do like blue-green deployment strategies or rings. There'd be different things available to me to more gradually roll those things out in a certain pattern. So this was manual. Okay, I can manually update things. But there is also the idea of automatic upgrades. It's PaaS. Shared responsibility, but hey, I want you to just go and do these things for me. So the next thing I could do is this idea of auto upgrade. Now with auto upgrade, it's the control plane and it's the nodes. It's going to reimage the nodes. It's going to go through, do that rolling update, the surge, cordon, drain, reimage. It's going to always do that because it has to. The node pools, remember, can only be 2 minor versions behind. And if I'm doing it in an automated manner, well, I couldn't risk that, hey, I'm automatically updating the control plane and the user forgets to ever upgrade the node pools. We could break things. So auto upgrade will always do the control plane and do the node pools. It's always going to upgrade everything. There's no concept of control plane, only in that automatic mode. I can select how aggressive I want to be. Now remember, we have that major, minor, patch. I could say patch auto upgrade. And if my current version is x.y.z, what patch will do is it will go to x.y.latest of Kubernetes. So if I was on 1.23.2, it might take me to 1.23.14. But imagine the idea that actually what's available is, well, hey, there's 1.25 and 1.24, and sure, that 1.23. If I was actually on, let's say, 1.23.4, in fact, let's exaggerate these out to make up some numbers. If I was on 1.23.4, if I say patch, it will not update the minor version, but it would move me to, let's say, okay, 1.23.13. That's what it would move me to. Or I can say stable. What stable will do is it will move me to, never going to change the major version, but it will move me to the latest minor version -1 dot latest. So it's going to keep me one minor version back than the newest. So if the newest was 1.25.3, sorry, it would move me to 1.24.9. It's one minor version back from what is new, so 1.24. Or I can say rapid. This might be good for my canary environment or maybe some early testing environments. This would move me to just the latest minor version that's available and its latest patch. So in this case, 1.25.3. So I pick how aggressive I want that auto upgrade to be. And all of these are basically upgrading the Kubernetes components. Now, as a side effect of that, remember, it does re-image the nodes as well. And we're going to talk more about this node image in a second. But they're really focused on upgrading the Kubernetes version. But because it upgrades the node pools as well, those node pools will also get re-imaged with the latest image version for whatever version of Kubernetes that is. So as a side effect, it is going to re-image my nodes as well. So they'll get, hey, the latest weekly if it's Linux, set of patches and all those other good things as well. There is another option. I can also select node image. This is not changing Kubernetes at all. This is not modifying the control plane. This is not focused on bringing the nodes to a new set of components for a new set of Kubernetes. This is leaving the Kubernetes version as it is. So I'm still going to be running on x.y.z. But imagine I've been on x.y.z for a while. Every week, as we're going to see, Microsoft create new images for the supported versions, which has, for example, OS patches for Linux built in. Maybe what I want is it to just constantly every week rebuild all of my nodes so they've always got the newest Linux patches. And if it was kernel, I don't have to worry about reboots or any of that stuff. So my other option is, hey, I want to do node image. Just keep that up and running. So I have those options. When I think about the use case, Stable is probably what you're going to use in production. Rapid, I might use in canary environments where I'm doing my early testing. Now, your dev test gets a little bit trickier because I do have to think about, well, really, our testing should match production. So probably testing would be something very similar to this, if we're talking about automatic. So as part of my process, remember, I never want to put something into prod that I've not tested on that same version. But at the same time, I wouldn't want maybe prod and test upgrading the exact same moment. So I want to make sure, hey, a final test, I'm in a good position there. So as part of my process, I would want an early access to make sure I can discover if there was some API deprecated, so I get to see and actually put that in place. And once again, I turn this on. So that's going to be interesting because I've done a manual upgrade. But you can go and see what your auto upgrades. And it's very easy to set. But if I was to look at my environment, let's have a look up here. I would see somewhere, if I can remember where it is. So you can see the Kubernetes version again. There we go. Auto upgrade profile, and I set it to stable. So that's what I have configured. So it would automatically upgrade me to the latest patch version of one back from the current minor version. So that's what I had configured in my environment. But obviously I just went and manually moved to the latest minor version that is available. And notice we can now see it's finished. It moved it back. So now back to one node because it completed that entire upgrade process. And actually it's back to that single number. So that's the idea of automating that. And that's great. Okay, so it's going to automatically, if I want, and that's a choice, worry about the Kubernetes side of things. I don't have to think about the control plane. Again, in my procedures, my deployment strategies, I want to make sure I don't just have some upgrade happen to prod that I've never tested. So I do want to make sure I have something on an earlier version. As my part of my DevOps process, I am testing things to make sure I don't just get shocked by that. But certainly, that is available to me as a tool. And then we have the operating system. Now remember, the operating system could be Windows, could be Linux. If it's Linux, it could be Ubuntu or Mariner, the Microsoft's own really stripped down but super secure, because it's only got the required components for example, running a container available to me. So we have these OS images. When I think about the OS images, well, right, there's Linux, which Ubuntu is the default today, but I can also use Mariner. I think maybe over time the shift might happen to Mariner. And I can have Windows Server. And it's sort of, I think today it's 2019 and 2022. Maybe that's in preview, could be wrong. So these images are what are used when I create nodes. For Linux, they rebuild these weekly. So every week they build a new version of all the different images they need. So those 3 minor versions, the 2 patch versions within those, for Ubuntu, for Mariner, there are some special ones if you think about maybe certain FIPS or Generation 1 and Generation 2 VMs. There's a whole bunch of images they automatically build every single week. For Windows, it's monthly. But these include, at the time of build, all the latest patches for their respective operating systems. And they include the latest system pod images. Again, for the various versions of them. And it's doing these for that N-2 minor versions. It's building all of these different images available to me. So it's constantly every week making a new image version, which is what this does. This node image, if I do the auto upgrade, what this basically says is every week, hey, when there's this new node image, automatically roll that latest image out to my node pool. So it's constantly getting these to the latest patched version. Because it's rebuilding them, if there was like a kernel update that required a reboot, well, it's done for me. I don't have to think about trying to reboot things because it's now built into the new image that it's rolling out. And there are shifts in the exact version. Like Ubuntu was 18.04, but now I think with 1.25 and above, it's going to 22.04. There are, again, different ones for confidential VMs and Gen 1 and Gen 2. There's a whole bunch of these. But the key point, weekly for Linux, is building a new one. Latest patches that have been rolled out since the dawn of time into it. The latest container images to build those system pods are baked in. And you can see the rollout of these. So it gets this weekly rollout. It follows the regular safe deployment process. So we can see the version that's currently in operation. And we can actually see the order it rolls them out to. So we can actually see, well, West Central US has 22.10.30, as does the second UK South, but then East US is 10.23, East US 2. You can see it basically rings. So it gives me time, they can safely roll these out and test them, check the stability. So you as a customer can see this, you as a customer can see the order the images are rolled out to. So I could have deployments in different regions, say, hey, I want to see some of this early, or maybe I'll stand sync up in West Central US. Or maybe I'll stand sync up in some of these other regions. But at any time, I can see the rollout progress of the various images. And you can see, hey, in progress right now, hey, the 1030 is rolling out. You can see all of the history. I can click on one of them. And I can see the release notes. I can see what's changed. So these images are all the different, again, Linux versions, and then the components of Kubernetes baked into it. So this can just be pushed to the nodes and then be ready to be part of that all-up environment. Okay, so I can see the rollout order. I can see all of this great information. Is that it? Is that the only thing that happens? Well, there's another thing that happens for the Linux. So yes, the images get updated. But additionally, if I think for my Linux operating systems over here, there is another mechanism. Every night for my Linux, there is a Linux nightly patch. And this is just installing the latest patches onto the operating system since whenever that image was. Now, again, if I was imaging very frequently, it just may be the last few days of patches. But every night it's doing that. This is not AKS pushing this. This is not Kubernetes. This is Ubuntu. The same as within the guest OS, I could run apt-get update and apt-get upgrade yes. It's like a Windows auto upgrade. It's an OS component is saying, hey, are there patches for me? And it's checking it every night. If there are, it sees them, it does it, and it installs them. This today behavior, I think, is going to change because the challenge with that, because it's the OS, it's not managed by the orchestrator in any way, well, these will get pulled to everything. Dev, test, production. And obviously there was an issue a few months ago where this caused a problem. So I think they already talked about there's going to be some changes coming, and maybe I could add in some lag. So maybe in production, it's going to lag behind even this sort of patching. So I could stop a patch hitting prod and dev at the same time. Now, what if this update here, it installed some kernel update that required a reboot? It cannot automatically do that. It's not going to automatically reboot the nodes. Remember, there's issues with rebooting. It takes out capacity. When I re-image, it does the search. it handles that. But just saying inside the OS, if it just started rebooting, that would be a bad thing. It might take out 3 out of 4 nodes at the same time. So if it needs to reboot, what it actually does is it touches a file, and touch just means it creates a file. So if I need to reboot, it's going to create a file, var run reboot required. That's it. As part of that nightly update, it saw a kernel patch that requires a reboot to take effect. I can't reboot. I'm letting you know. I could go and look at the VM instances inside that VM scale set and notice, oh, hey, look, that file's there. I need to do a reboot. So I could manually go and do the reboot, or there are solutions like Kubernetes, which basically sits and watches for that file, and if it sees it, it will automate the reboots. So this Kubernetes is the Kubernetes reboot daemon. Its job, look for if a reboot's required and do it for me. So then it would automate those reboots when, this is only maybe 4 to 6 times a year. It's not frequent as a kernel thing that requires a reboot, but if it was there, it would reboot the nodes. Or update the images. Remember, those weekly images have these patches. All of these patches, they're also getting cached and built into those weekly builds. So sure, nightly it's pulling down those patches and maybe one of them required a reboot, okay? It's not rebooting, but if I've got a pretty good set of processes in place that it's re-imaging the nodes, maybe every few weeks or month, whatever that might, maybe whenever there's a new patch version comes along, I re-image them. Well, I don't need to do a reboot to apply the kernel patch because that kernel patch is in the latest image. When it re-images the node, it's got it. So I don't have to worry about QAD and rebooting or any of those things. It's just going to be baked straight into it. So I do have those choices available to me. And that's really it. Now this maybe looks worse than it is. Key point when I think about AKS, yes, it's PaaS, yes, it's managed. There's still shared responsibility. It supports the 3 latest minor versions, so the N-2 I can go back to. So I can think, basically, when a new version's released, I can use it for about a year. The best practice, what I would say, is every 6 months, for example, upgrade. You're never then getting in with this tight window where, oh my God, I'm out of support in 2 weeks, I need to hurry up. You have a nice comfort barrier there. I can manually do the upgrades. I could just update the control plane, or I can say, hey, control plane and the node pools. If I just do the control plane, I can then node pool by node pool update its Kubernetes components. Remember that update for the Kubernetes components is done by re-imaging the nodes in the VM scale set. I don't lose capacity because I can use Surge. It adds an additional node and I can control how many. By adding how many, I can control how quickly it finishes because, hey, I can do 2 or 3 Surge nodes or whatever percentage I want. It can do those then concurrently. So there's not really an impact to my workloads. Realize though, Surge uses up resources from a quota perspective, from an IP perspective on my virtual network. I also can automate these things. There's automatic upgrades. And if it does auto, it will do the node pools as well. Because the node pools can't drop more than 2, it's basically 2 versions behind. So it's going to keep those updated as well. I can say how aggressive I want that to be. Stable is a very good one for production environments. It's 1 version back from the current minor version, but the latest patch. And then I would want some environment where I have, hey, the actual rapid, the latest, so I can do testing and see if something's going to break before it goes and hits my production environments. Microsoft for Linux does update an image every single week for all of the supported minor versions, the supported patch versions. So when I do these Kubernetes and I roll out the new Kubernetes components to my nodes, as a side effect of that, it is re-imaging them from the latest image, which will have all those patches in as well. In addition, it does do a nightly check on Linux. If it was a kernel required to reboot, it will touch a file. I then manually can reboot. I can use QRD, or again, if I am fairly routinely updating those images, well, it would have that built in anyway, and I'm good to go. So just make sure you have a good process in place. Don't let yourself fall behind. Kubernetes only supports minor versions for a year. AKS is N-2, which equates to the same thing. I don't want to be running something that's not supported by AKS and it's not supported by Kubernetes. I'd just be in a world of hurt if there was actually a problem. I hope that cleared things up. As always, till next video, take care.